In this video, I'm going to go through some exam questions that are based on predicting the shapes of molecules. I'm going to do an example for you first, then I'm going to get you to do some exam questions, and then I'm going to go through the answers. This is a really common exam question, okay? They ask you for the shape, and then they ask you to explain why it has that shape. In this case, they've drawn it for you. Because they've drawn it for you, you just need to count the bond pairs and count the lone pairs around the central atom. Okay, so my central atom is going to be phosphorus. Around phosphorus, I've got 1, 2, 3 bond pairs, and then I've got 1 lone pair. Because I've got 3 bond pairs and 3 lone pairs, I know that the shape is going to be trigonal pyramidal. In this case, you're not asked for the angle, but often they do ask you for the angle as well. You need to learn these shapes off by heart. You need to learn the angles off by heart. Okay? Then they ask you to explain. When you are explaining, there's very specific things that they want you to say. Okay? So the first part of your explanation is going to be that you had 3 bond pairs and 1 lone pair around the central atom, or around phosphorus. The second part of your explanation is going to be that pairs of electrons repel each other. Okay, so I'm going to write electron pairs repel each other. Now this mark they are really specific on. If you say electrons repel each other, you don't get the mark. It has to be electron pairs. If you say the atoms repel each other, you're not going to get the mark. You have to say electron pairs repel each other. And the final thing you can say is that lone pairs repel more than bond pairs. Okay, if you stick with that format, you'll always get full marks in these questions. Okay, state the amount of electron pairs you have and specify whether they are bond pairs or lone pairs. So 3 bond pairs, 1 lone pair. This is around the central atom. Then say that electron pairs repel each other. Make sure you're saying electron pairs, not just electrons, not just bonds, not atoms. Electron pairs repel each other. And then final point, just say lone pairs repel more than bond pairs. If you follow that format, you will always get full marks on this question, and these questions are really common. Okay, I've included more exam questions that start on page 5 of your booklet. Have a go at the exam questions by yourself, and then come back here when you're finished for the answers. First question is multiple choice. They've drawn the molecule for you. You can see you've got 3 bond pairs. You've got 1 lone pair. They want to know the shape and the angle. Okay, I've been calling this trigonal pyramidal. You'll see in your box that your only option is just pyramidal. Okay, it's the same thing. They just haven't used the word trigonal. Okay, but you've got 2 different bond angles, 104.5 or 107. You need to know if it's pyramidal. The bond angle is 107. So to answer that question, you just need to have learned your shapes and learned your bond angles. The next one is another example of that. Predict the shape and angle. If you've got 2 bond pairs and 2 lone pairs, 2 bond pairs, 2 lone pairs is going to be non-linear 104.5. So you can also call that shape bent instead of non-linear, okay? But the angle is always going to be 104.5. It's something you just need to learn. They want to know the shape of the molecule. Okay, so carbon is my central atom. I'm looking at carbon and I see I've got 1, 2, 3 bonding regions. 3 bonding regions means it's going to be trigonal planar, which is answer number D. Remember, when you've got double bonds, you're just counting it as a bonding region. So you're not saying you've got 1, 2, 3, 4 bonds. You're saying 1, 2, 3 bonding regions. It makes it trigonal planar. Question 4, you've got 4 atoms labelled and they want to know the one that has a trigonal planar arrangement of bonds around it. Okay, to be trigonal planar, you need to have 3 bonding regions or 3 bond pairs. Okay, if I look at this carbon here, this carbon is bonded to 3 hydrogens and 1 carbon. So it's got 4 bonds around it. It's not trigonal planar. If I look at option 2, this carbon has got 1 bond to a carbon, a bond to a nitrogen, a bond to a hydrogen, and a bond to another carbon. Again, it's got 4 bonds around it. It's going to be tetrahedral. This nitrogen, okay, has 2 hydrogens, and a bond to a carbon. So it's got 3 bonds around it, but we have to remember that nitrogen also has a lone pair, and 3 bond pairs, 1 lone pair is trigonal pyramidal. That leaves me with atom number 3, which is carbon. It's got 1, 2, 3 bonding regions around it. 3 bonding regions means it's trigonal planar, which is what I want. So my answer is going to be C, which is atom number 3. Question 5 is slightly longer. You need to actually draw the dot cross diagram yourself. Okay, so I've got carbon double bonded to an oxygen. So I'm going to draw my carbon. And I'm going to draw my chlorines down here. Okay, carbon is double bonded to oxygen. So I've got 2 carbon electrons between carbon and oxygen. It's single bonding with each of the chlorines. So that's the 4 carbon electrons already drawn. Oxygen's in group 6. It's got 6 electrons. 2 of those are going to be forming a double bond with carbon. Then it's got 2 lone pairs. Chlorine's in group 7. It's got 7 electrons. 1 of those electrons is going to form a bond with carbon. The other 6 electrons in each chlorine are going to be present as lone pairs. Okay? When you're looking at the shape, we are looking at the central atom. So you are looking at carbon. You can see that carbon has got 1, 2, 3 bonding regions. If it's got 3 bonding regions, it's trigonoplanar. Remember that double bond just counts as 1 bonding region. Then it wants so that's your first mark, trigonoplanar. Then it wants the explanation, and you are going to say that there are 3 bonding regions around carbon. And then you're going to say electron pairs repel. Okay? 3 bonding regions around the carbon. Okay, there's no lone pairs, so you're not mentioning lone pairs, and then you need to mention that electron pairs repel. If you just said electrons repel, you won't get the mark. You have to say electron pairs repel. If you said that the atoms repelled, you wouldn't get the mark, or the bonds repelled, you wouldn't get the mark. You have to say electron pairs repel. You don't need to mention that lone pairs repel more than bond pairs, because there are no lone pairs around your central atom. It's not going to be relevant. Okay, the next one we've got is number 6. Okay, this is slightly more difficult because you've got lots of different atoms. They want to state the shape and bond around a carbon atom in the alkyl group of propanoic acid. So you're looking around a carbon atom, but you've got 1, 2, 3 different carbon atoms. Okay, if they're talking about an alkyl group, they just want a carbon bonded to normal hydrogens. They don't want carbon double bonded to oxygen. Okay, so this carbon here is part of the carboxylic acid group, but the other 2 carbons in the molecule are part of just the alkyl chain. Okay, they're just single bonded to hydrogens. So if I look at either of these carbons, I'm going to look at this one. What is the shape? Well, this carbon has got 1, 2, 3, 4 bond pairs. If it's got 4 bond pairs, I know the shape is going to be tetrahedral. Okay, the bond angle, if it's tetrahedral, is going to be 109.5. And again, you just need to know those bond angles. And then my explanation, I'm going to say that there are 4 bond pairs around carbon. And again, I'm going to say that electron pairs repel. Not electrons repel, not bonds repel, not atoms repel, electron pairs repel. Again, don't need to mention lone pairs because there are no lone pairs around the carbon. Suggest a value for the COH bond angle in propanoic acid. Okay, COH, the central atom, the way they've written it is oxygen, so they want to know the angle around oxygen. Okay, so oxygen you can see has 2 bond pairs around it, but we need to remember that oxygen has 6 electrons in total. It's forming 2 bonds. But what's not drawn is that oxygen also has 2 lone pairs. So oxygen has 2 bond pairs and 2 lone pairs around it. 2 bond pairs, 2 lone pairs, the shape is going to be bent or non-linear, and the angle is going to be 104.5 degrees. Next question, number 7. They want you to predict the COH bond angle and explain the shape. We've just had this above, okay? So this is your COH. If I draw that out in full, you've got an oxygen bonded to a carbon. It's also bonded to a hydrogen. So you've got 2 bond pairs around the oxygen. But you need to remember that even though they're not drawn, that oxygen is also going to have 2 lone pairs. Bond angle is going to be 104.5. Okay. Oh, they do tell you that it's non-linear. So you should hopefully see the non-linear and think 104.5. But then you need to explain. Okay. In your explanation, you need to state that there are 2 bond pairs and 2 lone pairs around oxygen. Then you're going to say electron pairs repel. And then, because you do have lone pairs, it's relevant to add that lone pairs repel more than bond pairs. So you'll see that this question is worth 4 marks, 1 mark for the angle, 1 mark for saying how many bond pairs and how many lone pairs you have, and do specify the difference between the bond pairs and the lone pairs. 1 mark for saying that electron pairs repel. Make sure you're saying electron pairs are repelling. And then your final mark for lone pairs repel more than bond pairs. This sentence is relevant in this case because you've got lone pairs around your central atom. The last question, nitrogen forms NH4 plus and NH4 minus. Predict the name and shape of the bonds in each case. Okay, so if you had NH4 plus, okay, you've got 4 hydrogens around your nitrogen. Okay, we've seen this before. One of them is going to be a dative covalent bond, but you still have 4 bond pairs around nitrogen. That means you are going to have a tetrahedral shape. And your bond angle is going to be 109.5. Okay, if you've got NH2, you've only got 2 bonds around the nitrogen. So at this point, you're going to have to consider the lone pairs also around the nitrogen. So we know nitrogen has got 5 electrons in total, but we can see that you've got a minus ion, which means that there's an extra electron in there. That means nitrogen now has 6 electrons around it, okay? It's got 1 electron here in this bond with hydrogen that I'm going to draw in, okay? But now, as well as having its own lone pair, it's got a second lone pair, okay? Nitrogen usually has, I'll actually draw the extra electron in a different color. So nitrogen usually has 5 electrons around it. Because it's got a negative charge, I can see it's gained an electron. So it's got its own 5 electrons, the 5 black dots. It's got 1 extra electron, which is the red dot. 2 of its electrons are involved in bonds. It's NH2, so 2 of those are involved in bonds. But now it's got another 4 electrons. They will sit as 2 lone pairs. So now you've got 2 bond pairs and you've got 2 lone pairs. The shape is going to be non-linear or bent. And the angle is going to be 104.5 degrees. That one is slightly harder, and it does say in the mark scheme that most people struggled with the NH2 minus. Okay, if it's got minus, it's got an extra electron. It's going to give you 2 lone pairs around the nitrogen atom.